Hello again, this is Professor Zawolo, and today we're going to be going over the WAEC Senior Secondary School Mathematics Examination for Liberia. We are working on the Section B, Algebraic Processes, and Subsection F, which has to do with graphs of linear and quadratic functions. Today we're going to go over how to determine the maximum and minimum point of a quadratic function, and also learn how to find the intercept of the graph of a quadratic function and to solve a system of a linear and a quadratic equation simultaneously. So the first thing, let's go over some basic theory. So the first thing, let's talk about quadratic equation. You already know what it is. It's quadratic function. Let me call it function, not equation. It's a function. It has a form f of x equals to ax squared plus bx plus c. The graph of this function looks like a U, and this U can turn up. There's a point right here. This point is called the vertex. The line that runs through it is called the axis of symmetry. So it gives symmetry to this graph. The coordinate of this point, we usually say this line has an equation x equals h. And so the coordinate of the vertex is h comma k. Now, to find the value of h, there is a formula. Once the equation is in that form, h is equal to negative a over what? Negative b over what? 2a, where a and b are the coefficients, the real numbers in the formula. Once you know h, you can find k by k will be equal to f of the value of h. That will give you the vertex. Okay? Now, like I said, this quadratic equation could have been turned that way. In this case here, the value of a here is greater than 0, which means a is positive. And because this point is the lowest point on this graph, when a is positive, this graph has a minimum. The minimum is located at the vertex. Now, the second case we're going to look at is for this graph over here. Like I said again, this graph will also be turned down. So we look at this point being our vertex. We have our equation x equals h. Yes, my vertex here, my graph looks kind of awkward. Let me make it look a little much more beautiful. This is my vertex. My vertex has coordinate hk. We find the vertex the same way we did on this side here. The only difference here in this case here is that. So the vertex is going to also be the same, hk. The difference here is that a is less than 0, meaning a is negative. And this graph has, this point is going to be a maximum point. This graph has a maximum at the vertex. So, alright, and the other theory we want to talk about is the intercepts. So let's look at the intercepts. So if I have a quadratic equation, say this point here, x1, and this point x2 will be my x-intercepts, and they can be solved. These are the same as the roots of the quadratic equation, and this point is my y-intercept, and at this point we want to say here x equals to 0, and over here at this point y equals to 0. So with this concept, we can move now to solving some basic problem. Let's do first example number 1. So we have the equation y equals negative 3x squared plus 6x minus 8. And we want to find the maximum. Find the maximum point. Where the maximum point is the vertex, so by rule, to find the x coordinate of the vertex, we can say we know that a is negative 3, b is 6, c is negative 8. So to find the h, we do h equals negative b over 2a. So I have negative, my b is 6 over 2 times negative 3. So I have negative 6 divided by negative 6. That's going to give me positive 1. Now to find my k, the y-coordinate of the vertex, k will be equal to this function f evaluated when x is 1. So that's negative 3x squared plus 6x minus 8. I'm going to substitute negative 3, put a 1 in here, plus 6 times 1 minus 8. Flip over here instead of 1. So this is negative 3 times 1. That's negative 3 plus 6 minus 8. So I'll do it step by step to avoid that crazy mistake. So I'm going to have what? Positive 3 minus 8. So that's going to be negative 5. So basically, for my vertex, I have my vertex to be at, my vertex is, x value for my vertex was 1, and my y value was negative 5. And because a was equal to negative 3 and negative 3 is less than 0, this graph has a maximum at 1 comma negative 5, the vertex. So this is how you will find a coordinate of the vertex. There are other techniques you can use, but this seems to be one of the best methods you can use. You can also see if you can rewrite this problem in vertex form again, but this is the most, it's going to be the best way you can do a problem like this. Okay. So now let's do another example, example 2. In example 2, we've been given y equals x squared minus 3x minus 18, and we want to find the intercepts. Let me change that and say find A, the x-intercepts. B, find the y-intercepts. These are fairly easy processes to go through. So let's do A. To find the x-intercept, we need to set this equation x squared minus 3x minus 18 to be equal to 0. So then we clearly see that we can solve this by either factoring, quadratic formula, completing the square. I think factoring would be best in this case. So we'll do x minus 6, x plus what? 3. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So we have x minus 6 equals 0. So x equals 6. So one of our x-intercept would be 6 comma 0, because at the x-intercept y is 0. And the other x-intercept would be x plus 3 equals 0. That would be x equals to negative 3. Again, that would be negative 3 comma what? 0. For y-intercept, we have to set x to be 0. So we go back to our equation and replace x with 0. So for b, so we'll do y equals 0 squared minus 3 times 0, finish, minus 18. So y will be equal to negative 18. So our y-intercept is, for the y-intercept, x is 0, and that's negative 18. Example 3. Example 3 is to solve a simultaneous, solve quadratic and linear equations simultaneously. So example number 3, we have solve x squared minus y equals 3 and 4x plus y equals 2. So this is a simultaneous equation. One is a quadratic equation by virtue of the square over here, and one is a linear equation. Now there are many approaches to this. I think these equations are lined up properly, and so what I'm going to do is that I'm going to solve them in a very interesting way. I'm going to put a 4x right here. I'm going to put a plus y over here and put a 2 over here. You note that I did not put the x squared under the, I did not put the 4x under the x squared because they are not like terms. But over here, negative y plus y will cancel. Then I have an x squared plus 4x equals to what? 5. So then I'm using elimination. I can bring everything on one side, plus 4x minus 5 equals to 0. And then I will solve this. So this is going to give me x plus 5x minus 1. because 5 times -1 is -5. 5 minus 1 is 4, equals 0. And then when I solve here, I will have x plus 5 equals 0, meaning x equals -5. X minus 1 equals 0, meaning x equals to 1. And so I have two x values as my solution. So correspondingly, I will have two y values as my solution. So I can go to the second equation. I did not number my equation. So let's go to equation 2. And I'm going to substitute this value into equation 2. So for equation 2, I have 4x plus y equals 2. Now I can rewrite this to get y by itself. Otherwise, I can do the first case. I have x equals -5. So I do 4 times -5 plus y equals 2. That's going to be -20 plus y equals 2. When I add this to both sides, I have y equals to 2. So one solution I have is -5, comma, y equals 22. But that's one of my solutions. The other solution, I have 4x plus y equals to 2. That case, x is equal to 1. I have 4 times 1 plus y equals to 2. This is 4 plus y equals to 2. Y is equal to -2. So my other solution is x is 1 and y is -2. So basically, we've gone over all three of the possible kind of problems you can have on this section. So again, what you need to do is to just do more practice on it. We're going to definitely be coming up with more videos that will support this topic. I know this is one of the most difficult topics, but so we're going to do more. But again, thank you. This is Professor Zawolo, and this has been done by the Foundation for Equity and Excellence in Education in Liberia, a foundation committed to ensuring that every Liberian child has access to high quality content instruction.